All right, welcome to Chapter 7, Section 7, called Area and Perimeter of Similar Figures. So a couple things, this is for Math 8, before I get into that. A couple things you'll see on your screen here is a due date. I don't see that on my teacher preview, but you should see it right here on your student screen. The second thing you'll see are number of attempts. There are always unlimited attempts on homework, tests, and quizzes. So you can come in and try them as many times as you would like. Number of questions just lets you know how many questions there are here for this particular assignment. Grading policy is best score, so whichever attempt is the best one is the one you get to keep. Partial credit is always enabled, which means that if you answer one of two questions correctly, you get credit for one question, or however many you answered correctly. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. What that means is when I click start, down in the bottom right corner here, you will see a submit assignment button. I know it's not right here on my teacher preview, but it will be on your student screen. And we want to click that button before we leave this screen. So whether or not we've started anything at all, or maybe we've only done the first one, we've gotten our little check mark here, we click submit assignment button. It does two big things. Number one, it stops the system from locking you out of all of your other assignments like that front screen said. It assumes if you just close the tab or close your computer, Alex will assume that you want to leave this attempt open. Remember, you have unlimited attempts. You don't need to leave this attempt open. You can come back in and try as many times as you want. As long as you have a green check mark on certain problems, it will save your place. It's only going to make you do problems you didn't try or you didn't finish, or ones that you got wrong. The other big thing that it does when you click submit assignment is it actually affects the gradebook, so your teacher can see what you've been working on. Until you click that button, your account is basically frozen. We can't see what you've been working on at all. So good habit, always click that button. On the side here, we have explanation, example, and message center. So explanation tells us we're going to lose a question attempt because it's going to give us the actual solution to this problem. So it's not going to give you the answer and then let you come type it in. Example will give you an example of something very similar to what you're looking at, walk you through how to set this problem up and what to do, how to solve it. Once you're happy with that explanation or example, you can close that. You can open another one if you'd like to see another one. You can also message your teacher directly from the screen, and it will attach a picture of this problem so that we know where to come help you. All right, let's go ahead and get started here. So a scale drawing for a restaurant is shown below. All right, so we have a scale drawing. In the drawing, 2 centimeters represents 8 meters. Sorry, I don't know why I said 8. I saw 8 here and said 8 meters. 3 meters. Assuming the dining hall is rectangular, find the area of the real dining hall. All right, so we need to, number one, kind of review what scale factor means. So remember, the drawing is smaller than the actual building, which makes sense. You wouldn't want to do a drawing the same size as the building. That wouldn't be terribly helpful. A scale model kind of helps us picture something before we build the entire thing. Or the layout when we put something together like this. So this drawing, is much smaller, obviously centimeters, than the actual kitchen and dining hall are going to be. But we know what the scale is. 2 centimeters represents 3 meters. So for every 2 centimeters on this diagram, it's 3 meters in the real world or in the real life. And we're assuming that it's rectangular and we want to find area. So we need to remember how to find area of a rectangle. So area of a rectangle, hopefully your rectangle looks more like a rectangle than mine, rectangle equals length times width. I mixed my D and my T together for some reason, which a lot of the time we just do L times W when we're saying length times width. So now we can go through and we can start looking at these pieces. So down below, if we want to know the area of just the dining hall, the kitchen is extra information, basically. We really don't need to know it, but they might have asked us a question about the kitchen or the dining hall. It didn't. It was kind of just by chance they asked us about the dining hall on this one. So they're giving you extra information. You don't need it. You just kind of ignore it. All I'm doing is going to focus on the dining hall here. So I know that the length of the dining hall, or the depth, I guess you could call it, I don't know, is 4 centimeters. And the width is 2 centimeters. So we want to go through and we want to start writing some ratios here. So let's see, we're going to find the length of the real dining hall, and we're going to find the width of the real dining hall. So I kind of actually like to give myself a little map. So I do drawing to real, and I set up a little proportion like this. So in the drawing, we have the length, and then width. Is that what I want to do? Let's see. Oh, scale. That's what we're going to do. Sorry. Scale. And then length on this side. We'll do it that way. Mess myself up a little bit here on the video. So the scale for the drawing and for the real, they give us that up above. So 2 centimeters to 3 meters. So we have 2 centimeters. I said 2 and wrote 3. 2 centimeters to 3 meters. And then the length for the drawing, we have, I'm going to just go with 2. I guess I'll call that one length and this one width. I don't know. It doesn't really matter which one's which. So we'll go with 2 here for the drawing, and we don't know for the real. And we can do, length, we can do X, we can do whatever variable we would like to do there, just to represent that real quick. And then we're going to do cross multiplication because we have a fraction equaling a fraction, which is a proportion. So 2 times L is 2L equals 3 times 2, which is 6. So then I'm going to divide by 2 on both sides because I want to get L all by itself. 2 divided by 2 cancels. So the length of the real dining hall is 3, not centimeters. We just converted that to meters. And if we think about that too, every 2 centimeters represents 3 meters. Well, I had 2 centimeters. So that represents 3 meters. So that was kind of, hopefully a little bit more obvious conversion there. So you can also do that with the other one. You can say, well, there's 4 here, and every 2 represents 3 meters. So there's 2 and 2. That would be 3 and 3. So I can kind of figure this out without even doing the proportion. If I really kind of thought that through, I could divide each one of these up, because that's another visual way to do this, is if I have 2 centimeters and 4 centimeters, well, this guy, 2 is 3 meters. 4, I can divide that into 2 and 2 again, right? Because I want to break it into the 2's. So this is 3 meters and this is 3 meters. So I can break it up that way too, if that makes sense to you. It depends on the students if that visual representation makes sense. I know that doesn't always. Sometimes the proportions don't always make sense to everybody. So we're going to do this again. Drawing and real. Scale. If I can spell scale. Scale. And this time we're going to look at the width. All right. Equals. Okay. So 2/3, that's still the same scale. That's not going to change throughout the problem. But now the width is different. The width of the drawing is 4 centimeters. We don't know the width of the real dining hall. So I'm going to use W. All right, so now we'll go through and we'll go cross multiply. 2 times W is 2W. 3 times 4 is 12. I'm going to divide by 2, divide by 2. W equals 6. And it's going to be 6 meters, not 6 centimeters anymore. We needed to know this. Neither one of these are the answer, though. We need them to complete the answer. Remember, area is length times width. So we have 3 times 6, length times width. And that will give us, and I'm just going to keep it in red for whatever reason, 18 meters squared, because it was meters and meters. So meters times meters is meters squared. And this is an area, meaning it's 2-dimensional. It has length and width. If it's just meters, like 3 meters and 6 meters, that means it's a length. It's 1-dimensional. It's just one, it's a length or it's a width, but it's not both length and width. That's when we have squared on there. If we had cubed, now we're talking about 3-dimensional, which is volume. We're looking at the entire building. The length, the width, and the height of the building, if we had cubed. So we're not looking at the volume right now, just the area. The other thing, and I think they might be introducing that to us on the next piece here. They are. So I'll wait till the next screen because there's another way to do this without having to go backwards to find kind of the length and the width. You can actually compare just the area of the scale versus the area of the real one. So we'll look at that on the next screen here because they are going to show us that. All right, let's erase all that. Okay, so now we have a pair of similar figures as shown below. Note the figures are not drawn to scale. When they tell you that, they literally want you to not try to take out a ruler or anything to measure these things. They don't want you to try to kind of go around having to do the calculations in some way and use some measuring tool to do it, because they're not drawn to scale. We're just assuming they are in fact similar objects or similar figures. So the sides BC and DE are corresponding. So they gave us that already. We know they're corresponding to each other. And we can kind of see they're in the same pattern here, right? I can see this kind of funky corner here, that fifth side that's kind of cut off. So it doesn't really make a rectangle. It makes a pentagon actually because it's five-sided. So use the information below to find BC in figure 1 and area in figure 2. So then if we go down here, we're shown the area of figure 1. We have 245 centimeters squared. The perimeter of figure 1 is 35 centimeters. And then they don't give us the length. That's what they want us to fill in for just this side. On figure 2, we don't know the area, but we do know the perimeter is 25 centimeters. And the length of DE is 5 centimeters. So on this one, what we want to understand is that not just the lengths are comparable when we're having corresponding or similar figures. The perimeters are corresponding. Perimeters are just the length all the way around. So that's just another length. So that one's definitely comparable, just like the length of a single corresponding side. The entire side perimeter all the way around should also be corresponding kind of to each other. Those are similar. They're multiplied by the same thing. So if we went BC to DE, we'd be dividing because we're going down. So the perimeter for figure 1 would be divided by the same thing as the side lengths. Ooh, excuse me. The area is also comparable from one similar figure to the other. So first, let's go ahead and look at what do we have on both. So on both of these, we have the perimeter. I have the perimeter 35. I have the perimeter figure 2 is 25. So I can go figure 1 and figure 2. And the reason I want to do this, so this is figure 1, and this is figure 2, I can get a scale from this because these are comparable lengths. So I can divide this down. They can both divide by 5. So if I divide by 5, I get 7. If I divide by 5 here, I get 5. So this is my scale factor from figure 1 to figure 2. It's a scale of 7/5. So now I can use this scale factor to find my missing pieces. So since this is a length, I don't have to change this scale to use it for the lengths for BC and DE. So remember, this was 1 and this was 2 for figure 1, figure 2. So BC is figure 1. So if I want to know BC, I'm just going to go X for that guy because I don't know it. Figure 2, I have 5 for the DE. Now, if we kind of just look at this proportion without even doing anything, if this is 5, it didn't change at all. So do we think that 7 is going to change at all? It's not. It couldn't in order for these to be the same. But we could go through and we could do the cross multiplication. 7 times 5 is 35. Equals 5 times x is 5x, and I could divide by 5, divide by 5. 5 divided by 5 cancels. 7 equals x, because 35 divided by 5 is 7. So before I even do this, though, I can look and see, okay, well, what do I have to do to get from here to here? Whatever I have to do, which I'm multiplying by 1, I'm not changing anything. I do the exact same thing on the top. So it's just kind of one of those things you can take a look at that proportion before moving forward to see, can I, fill this in, without the cross multiplication. And in this case, not too terribly hard if we notice, okay, well, 5 stays 5, so 7 must stay 7. All right, so we know that it's 7 centimeters and 5 centimeters for the lengths. Now I need to look at the areas. So I can still use this 7/5 for the ratio or the scale factor, but when I go to area, I have to square it because area is 2-dimensional. So I have to make this scale factor 2-dimensional. So 7 squared is 49 and 5 squared is 25. Make sure you square both the top and the bottom. So I'm going to use 49 over 25 instead of 7 over 5. So now figure 1, figure 2, like this, and I have 49 over 25. So the area of figure 1, I have that. That's 245. I don't have the area of figure 2, so I'm just going to use x again. It doesn't matter if you use the same variable. If you don't like that, you can use a different variable. Totally up to you. All right, so we're going to do cross multiplication here. So 49x, because 49 times x, equals 25 times 245. Let's use our handy dandy calculator for that one, because I don't want to mess up my 25s here. And that's definitely a nice big number. So 6,125. Our last step. This is multiplied by 49, so we're going to divide by 49. 49 divided by 49 cancels, so let's come over here and go divided by 49 equals, it did go in evenly, nice, 125. And this is going to be 125 centimeters squared. They already have the centimeters squared there, though. So this is just another way of going through and finding or comparing the scale factor from area and length. So if it's a length, it's all the same scale factor, whether it's one side or the entire perimeter. That's just length. We're just adding lengths together. But area, remember, that's 2-dimensional. Now I'm looking at length and width, even though I know it's not, truly length times width on this one. It's a little different, but that's still the same idea. It's 2-dimensional when we're looking at area. So we have to square that scale factor, and then we can compare. All right, so that was section 7, and that was it for today. We only had these 2 questions. I believe that is the end of chapter 7, so I will see you in chapter 8.